Hi guys, welcome back to the channel. My name is Jai, and in today's class, we're going to continue with our Chemistry 12 content. And today's topic is going to be the equilibrium constant. So with that, let's get started. All right, so here we are, okay, for the equilibrium constant. Okay, and what I'm going to do first is just write out the general form of this equation, okay? So I'm going to put K equilibrium. Okay, you can also put Kc in terms of the constant, the concentration of R over C, concentration of S over D, over the concentration of P to the power of A, and the concentration of Q, okay, and this is going to be to the power of B. Does everyone see that? Okay, and what this represents is basically just the concentration. So let's write it here, okay? So this is the concentration of the products over, okay, the concentration of the reactants. Okay, and so we're going to try like an example, okay, right here. Let's try this example, okay? So I have N2O4 gas, okay, and it's being converted to 2NO2 gas. Okay, I'm going to write the equilibrium constant expression here. So K equilibrium equals, you're going to take the product, which is nitrogen dioxide. Okay, and I notice how there's like a 2 in front here. Okay, the 2 or the coefficient just represents the exponent within the expression. Okay, it's going to be over the reactant. The concentration is N2O4, like this. I see there's nothing in front here. There's just a 1. So I'm going to leave the exponent as 1. Okay, and that's what the expression for the equilibrium constant is in this case. Okay, with that, let's look at one more example. Okay, let's try this one. So I have SO2 gas plus oxygen gas. Okay, and what it's forming here is going to be SO3 as a gas. Okay, so first thing I want to do actually is make sure that my equation is balanced. Okay, so I see the oxygen is imbalanced. I'm going to put 2 here. So 2 times 3, there are 6 oxygens. There are also 2 atoms of sulfur. Does everyone see that? And the only way I can balance that is by putting a 2 in front of the SO2. Okay, so I have 2 times 2, 4 oxygens plus 2. There are 6 oxygens altogether on the reactant side. And then there are 2 times 3, 6 oxygens on the product side. And 2 atoms of sulfur, okay, on both sides as well. So I can see this is the balanced equation. Okay, I need to find the equilibrium constant expression. I can also use Kc, okay, which means constant, okay? But in most cases, we do write EQ. So we'll just keep EQ as an equilibrium constant. Okay, I'm going to take the concentration of my product, which is sulfur trioxide. There's a 2 in front, which is going to become the exponent here. Does everyone see that? Okay, then you're going to do the concentration of the reactants. So the first is the concentration of sulfur dioxide, and it's squared, times the concentration of oxygen. Okay, and this is my equilibrium constant expression. Okay, does anyone have questions? It looks good. Okay, so now we're going to try an example, okay, where you're actually plugging in some values into the K equilibrium constant. Okay, so let's take a look at this. All right, so I'm going to put example here. Okay, let me read out the question first. A mixture of nitrogen and chlorine gas was kept at a certain temperature in a 5-liter task, or 5-liter flask here. So let's put that down, 5 liters. This is the equation that they give us. So nitrogen plus chlorine, and these 2 arrows going in both directions, that just means it's equilibrium. So 2NCl3 gas, okay? And that means that the reaction can actually go in both directions here, Okay, so when the equilibrium mixture was analyzed, it was found to contain, let's write down some values here. So for nitrogen, 0.0070 moles of nitrogen. Okay, these values do have to be given to you. And chlorine, 0.0022 moles, chlorine gas. Okay, and then lastly, the NCl3 was found to be 0.95 moles. Okay, and it says calculate the equilibrium constant for this reaction. Okay, before we actually write out the equilibrium constant expression, I have to make sure I actually calculate the concentration for each of the reactants and products. Okay, so let's start off with the concentration of nitrogen. Let's put like arrows. So it's C equals N over V. Okay, now we'll put it in going in one line here. Okay, so we can all see it. So 0.007 moles divided by 5 liters. Okay, put that in your calculator. We're getting 0.0014 moles per liter. Okay, so make sure you remember this equation, okay, from grade 11 chemistry. C equals N over V. N represents the number of moles and V represents the volume. Okay, and then let's go to chlorine, and we can calculate. So Cl2 again. Make sure you're always writing the equation out, okay? So C equals N over V, so 0.0022 moles divided by 5 liters. Okay, I'm going to put that in my calculator here, and we are getting 0.00044 moles per liter. Remember, you can write these numbers in scientific notation. Okay, I think it's easier if you're writing it out in the standard form so you can see it. Okay, and then lastly, let's do NCl3. So same thing, okay? So C equals N over V. I'm going to take 0.95 moles divided by 5 liters, like this. Okay, and I'm getting 0.19 moles per liter, okay? So these are the concentrations that I'm actually going to use in my equation, okay? So we're going to write out the K equilibrium constant expression. Okay, and it's based on what we have here, okay? So let's take the concentration NCl3. I'm going to square it because I see a 2 in front as a coefficient. And it's going to be over concentration of nitrogen times the concentration of chlorine to the power of 3. Does everyone see that? Okay, so we're just doing the concentration of the products over the concentration of the reactants. Okay, then we're going to plug in our values, okay, that we did get over here on the side as the concentrations, okay? So the bottom one is NCl3, okay? So we're going to put it in brackets, so 0.19 squared, okay, over the nitrogen, which is the top one here, okay? So 0.0014 moles per liter. Okay, there's no need to actually write down any of the units here when you're plugging it in. Okay, and then times the chlorine, which is 0.00044 to the power of 3. Okay, so make sure you don't forget to put the powers down here. Okay, you can put this directly into your calculator, and what we're getting is 3.0 times 10 to the power of 11. Okay, does everyone see that? The equilibrium expression has the product terms in the numerator as well as the reactant terms in the denominator. Okay, make sure you're looking at the exponents. Okay, the exponents should be matching. Okay, in terms of the corresponding coefficients and the chemical reactions. All right, and the molar concentrations at equilibrium were substituted into this expression here to obtain the final answer for the equilibrium constant. Okay, make sure you note that the equilibrium constant does not have any units here. Okay, and don't put any units or the teacher will take off marks. Okay, All right, so that looks good.
And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone next time. Thanks, bye.